Hi there, Tita Benigo here. Welcome to today's session. Alright, so in today's session, we're going to start looking at quadratic function graphs. Quadratic function graphs are very similar to quadratic equations, and they are of the form y is equal to ax squared plus bx plus c. You remember this from the sessions we had on quadratic expressions and quadratic equations. We had something similar to this. Yeah, so for this topic, we're going to be working with these formulas. So this is the one we're going to be using to find the coordinates, and this will be helpful when we're finding the maximum value of y or the minimum value of y or the coordinates of the turning point. So for this one, you can use either this one or that one. I'll get to show you when we are going to use each of those formulas. Alright, so we're going to start with an introduction. We're going to do a bit of linear programming because, like, as you can see, we're dealing with coordinates and we're dealing with the x or y plane. So we need to have some basic knowledge on linear programming. So we are going to start by looking at how you find coordinates, okay, on the x or y plane. So the vertical line is called a y-axis, while the horizontal line is called the x-axis, okay? And you'll see there are these readings that are on each of these lines. So on the x-axis, this is our 0, okay? So the 0 is applicable both for the y-axis and the x-axis. So from 0 on the y-axis, on the x-axis, from 0 going towards the left, you're going towards negatives, okay? And then from the 0 going towards the right on the x-axis, you're going towards the positive values, the positive coordinates. And then on the y-axis, from 0 coming downwards, you're going towards the negative coordinates. And then from 0 going upwards on the y-axis, you're going towards the positive coordinates. Okay, so now let us talk about location of points. How do you get to locate points? Let's say, for example, there was a point that was stationed here. Let's call it A. And then you're asked to find the coordinates of this point. The first thing you need to take note of is that the order of the coordinates starts with the x coordinate followed by the y coordinate. Okay? X coordinate followed by the y coordinate. So the first thing you're going to do is you check what is the x coordinate for this point. To check the x coordinate for this point, you need to go up towards the x-axis. This is the x-axis. So when you go up towards the x-axis, you notice to say that line is passing at what? At positive 2. So meaning the x coordinate for this point is going to be positive 2. Okay? And to check the y coordinate, we need to go towards the y-axis. This is the y-axis. So we're going to go to the left towards the y-axis. It's passing at negative 2. Therefore, the coordinates of A are 2, negative 2. That's how we read the coordinates. So this is 2, negative 2. These are the coordinates for A. Let's say there was another point at this point here. Let's put it there. Code B. Alright? What are the coordinates for this point? So remember we said you start with the x coordinate followed by the y coordinate. So we need to go up towards the x-axis. This is the x-axis. For us to get the x coordinate, so it is passing at negative 2, so it's negative 2, what? To find the y coordinate, we're going to go towards the y-axis, which is this one. So this one is negative 4. So meaning the coordinates for B are negative 2, negative 4. Let's do one last one. Okay, let's say the point is right here. Okay, let's say it's here, and let's call it C. What are the coordinates for C? We need to start with the x coordinate first. Let me put it here. Okay, so the x coordinate, we need to drop to the x-axis to get the x coordinate. The x coordinate there is what? Negative 1, the y coordinate, we have to go towards the y-axis. It's passing at 2, so meaning it's the y coordinate is 2. So the coordinates for C are negative 1, 2. Now, there's another important thing you need to take note of, and this is that all the points lying on the x-axis, their y coordinate, their y coordinate is always 0. Okay, so let's say there's another point here, or let's say right here, and this point is called D. Okay, the x, let's put the coordinates here. So D, the x coordinate is right where it's lying here. So it's lying at what? At 3, meaning the x coordinate is 3. What is the y coordinate? The y coordinate is 0, because this point is lying on the x-axis. So all the points that are lying on the x-axis, the y-coordinate should be 0. Why is it 0? Remember, we are moving towards the y-axis to check the coordinate. So if you move, you're actually going to be moving on the same x-axis. And then what's the coordinate here? The coordinate is 0. So meaning any point, if we had another point here called E, okay, the x-axis is right there where it's lying, which is -3. That is the x-coordinate. Okay, and then the y-coordinate is going to be 0, because you're going to go like this, and then this is the coordinate there for that point. So the shortcut is all the points that are lying on the x-axis, their y-coordinate is always 0. Okay, similarly, all points lying on the y-axis, their x-coordinate is always 0. Let's say you have another point here. Let's call it F. Okay, to check the x-coordinate, remember we have to start with the x-coordinate. We have to go up towards the x-axis. So when you go up towards the x-axis, we're going to find this coordinate here, which is what? Which is 0. Okay, and then what is the y-coordinate? Right there where the point is lying, it's -3. So if we have another point here, you go up, you still find the 0. Okay, so meaning this is going to be 0, -2. This is 0, -1. Because the x-coordinate for all these points that are lying here, even if you are coming from down here, you have to come down to this point. Okay, and you still get a 0 for the x-coordinate. So that is very important when it comes to finding these coordinates. And for example, if you're asked to find this coordinate here, because you know to say, so here you already know one coordinate for this point. Okay, this coordinate is lying at, is lying on the y-axis. It's lying on the y-axis. So since it's lying on the y-axis, the x-coordinate for this point is 0. These 2 points are lying on the what? On the x-axis. Therefore, their y-coordinates are going to be 0s. So that is that. Very, very important, and it will make this topic very simple to solve. Okay, so now that we have gotten that out of the way, let us now look at these exam questions we have. So the first one says, the diagram shows the graph of the function y is equal to x squared plus 2x minus 15. The curve cuts the x-axis at A and B. A and B, the curve, this curve. It cuts the x-axis at A and B, okay? And the y-axis, it cuts the y-axis at point what? At point C. And then this is the equation of the curve, which is the same as what has been given in the question. And then the question says, find the Roman numeral 1, coordinates of A and B. Roman numeral 2, minimum value of y. So, excuse me, to find the values of the coordinates of A and B. Remember, A and B are lying on what? The x-axis. So we already know to say the y-coordinates for these points are going to be 0s. So now, in order for us to find the x-coordinates, all we have to do is we get this equation of the curve, okay? And then we solve it as a quadratic equation. Once we solve it, remember when you solve a quadratic equation, you have to find 2 answers. Those 2 answers you are finding are actually the coordinates, the x-coordinates for these 2 points. Alright, so let us solve that one as a quadratic equation. So in other words, the way of basically forming that quadratic equation is because, remember we said this quadratic function graphs are of the form, this one, right? So where is the 0 coming from? Because you remember quadratic equations are supposed to be equated to a 0. So the 0 is coming in because these points are lying on what? Are lying on the x-axis. Therefore, the y-coordinate is going to be a 0. So that is why this this y is going to be replaced by a 0. Thereby, we're going to have a quadratic equation. So we have ax squared. We have that x squared plus 2x minus 15. That is our equation, and then we're going to say is equal to 0. Initially, it's supposed to be y, is the way it is. Y is equal to that one. But because these points are lying on the x-axis, meaning the y-coordinate is going to be 0. So that is why this y has been converted to a 0, thereby making it a quadratic equation. Now that we have done that, we're now going to solve the way we are solving quadratic equations. So we need to first of all determine, has it been arranged according to the quadratic format? Yes, it has, as you can see. The first term is squared, the second one has a variable raised to the power of 1, and then the last one is a constant. So we need to have a data table here. We need A, B, C, the sum, the product, and the factors. So what is our A? Our A is 1. Okay. What is our B? Our B is 2. Our C is negative 15. Okay. And then sum is the same as B, so it's going to be a 2. The product is found by multiplying A times C. A times C. So 1 times negative 15, we're going to get negative 15. Like that. Okay. So now we need to come up with the factors. So we need to come up with numbers that can go into 15 without leaving a remainder, starting with the smallest, which is a 1. Okay. We simply divide this small number by that to find the next number we should pair this one with. So 15 divided by 1 gives us a 15. Close the bracket, open the next one. Okay, what's the next smallest number that can go into 15? It's a 3. Okay, 15 divided by 3 gives us the number we should pair it with. And then here we have to make sure that the biggest number, so I'm cruising at this point because we've been doing this from quadratic expressions to quadratic equations, and again we're here doing the same thing. So at this point I expect you to understand everything that's going on. So that's why I'm closing. Alright, so we have to make sure that the biggest number in each bracket has the same sign as the sum. So our sum is what? It's a positive number. So we're going to make sure that this guy is positive and that guy is a positive. Okay, and then we test. When you multiply these numbers, are they giving us negative 15? 1 times positive 15 gives us positive 15. So they are not giving us a negative number. So meaning this guy has to be a negative, that one a negative. When you test now, you find that the numbers we're going to be getting, the products are going to be negative 15s also. So negative 1 times positive 15 gives us negative 15. Negative 3 times positive 5 gives us negative 15. Having confirmed that test, we go to the last test. Which of these two brackets can we add to get positive 2? So we're going to try the first one. Negative 1 plus 15. We're going to get to positive 14. Okay, this is not our sum. Our sum is positive 2. So meaning these are not the numbers we're looking for. Next one, we try this one. Negative 3 plus 5. This will give us positive 2, which is our sum. Our sum is positive 2. So these are the numbers we're looking for. And at this point, I'm now going to show you that shortcut again. Alright, so having found these factors, the factors we're looking for are what? Negative 3 and positive 5. These are the numbers we're looking for. For this shortcut, there's no need for you to plug in the variables. Okay, simply pick the numbers the way they are, and then you come back to your equation. Alright, so here there are two x's, right? X squared simply means there are two x's there. So you open two brackets like that, and then you equate them to 0. There are two x's here, you put one in here, another one in there, and then you simply plug in these numbers. In one you put the negative 3, in the other one you put a positive 5. Okay, you now remember this step. So we're skipping the process of factorizing by grouping until we get to this point. So that is all we are skipping. We are getting to this point from here. At this point, we're now going to equate each bracket to 0 and then solve for x. So it's going to be x minus 3 is equal to 0, or x plus 5 is equal to 0. So x is going to be equal to 0 plus 3. When this negative 3 crosses, it becomes positive. X is equal to positive 3. Or x is equal to 0 minus 5. When the positive 5 crosses, it becomes a negative. And then we're going to have negative 5. So these now are the x coordinates for the points A and B. So now at this point, remember we said from 0 coming this side, we're going towards what? The negatives. From 0 going this side, we're going towards the positives. So meaning this A, the coordinate for A is the one that is in the negatives, which is the negative 5. And then the coordinate for B is going to be, the x coordinate is going to be that one. Okay. So the x coordinate for A is going to be the one in the negatives. The x coordinate for B is going to be the one in the what? In the positives. So therefore, the coordinates of A are going to be, what is the x coordinate? Remember, we always start with the x coordinate. So A is one that is lying in the negative region. So meaning we're going to say negative 5, comma what? Comma 0, because we know to say any points lying on the x-axis, their y coordinates are going to be zeros. So those are the coordinates for A. The coordinates for B, So B is in the positives. So meaning it's the one that's going to capture the positive x coordinate. So it's going to be 3, comma 0, and we are done. These are the coordinates for the points A and B. Where are we? Right here. So now the next one, we're asked to find the minimum value of y. So the minimum value of y is basically this point here where the curve is turning like this. All right. So this question is solved the same way. Whether they ask you to find the minimum value of y or the turning point for the curve, it's the same thing. So you're simply being asked to find the coordinates right here where the curve is turning from. So now remember, to find coordinates, you need to have the x coordinate and the y coordinate. So we first need to find the x coordinate using one of these formulas. All right. So now you can use this one or you can use that one. Doesn't matter. Both of them will give you the same answer if you solve them correctly, like the way they're supposed to be solved. So we're going to go with this formula. So first we need to find the x coordinate, and then we can use the x coordinate to find the y coordinate. So what we're going to do here is we're going to say x is equal to x1 plus x2 everything over 2. Okay, now we need to find these values. Where is x1 and where is x2? Where are we going to get these values? So these values are actually the same values you found in your quadratic equation. So if these values are wrong, this also becomes wrong. That is why you have to be very careful. So it doesn't matter which one you're going to assign as x1 or x2. Simply capture both of them. So we'll call this one x1 and then we'll call this one x2. Meaning we're going to now say x is equal to, while there's x1, I'll put a 3, plus, while there's x2, I'll put -5. Like that, and then I'll divide by what? By 2. And then I'll say x is equal to 3 minus 5 over 2. Positive times negative is negative. Okay, and then we're going to say x is equal to, there when the signs are different, you keep the sign of the bigger number, you subtract. 5 minus 3 gives us a 2 over 2. When we divide, negative divided by positive is negative. 2 divided by 2 there gives us a 1. So the x coordinate is 1. For the sake of testing, let's also use the other formula. Negative b over 2a, so that you can choose which one you find simple. At this point, where do you get these values a and b? Remember, here we have a, b. Okay, these values, if you remember our introduction to quadratic expressions or equations, we said a and b and c represent numbers. So you go back to the original equation and you make sure it is arranged according to this format. You simply extract the values of a and b. So here we already have that information on that data table. Our a is 1 and our b is positive 2. So meaning we're going to say negative 2, okay, negative 2 over 2, our a is 1, okay, our b is 2, where there's b we put 2, and then our a is 1, so where there's a I put a 1, and then I'll solve. Okay, negative 2, 2 times 1 is a 2, okay, which is going to give us negative 1. So you've noticed here we found the negative 1, even there we found the negative 1. So you can go for whichever formula you feel is easier to use. So that is that. At this point, now that we have found the x coordinate, we simply have to go back to the original equation here, which is, so this is, let's put it here, number 2, this is Roman numeral 1, which is y is equal to x squared plus 2x minus 5 is 15. It's saying 5. Okay, we go back to the original equation for the curve. And then since we already have the x coordinates, where there's x everywhere there's x in this equation, we simply plug in the value we found for x. And then you notice the only unknown value is going to be y. Such that when you solve this side, the answer we're going to find is actually going to be the y coordinate. So what we're going to do now is we're going to say y is equal to, there we have an x, so you need to plug in a negative 1. So we're going to put it in brackets like that, and then the power outside plus 2, negative 1, we close, minus 15. And then we simplify, we solve for y. Negative 1 squared gives us positive 1, positive times negative, negative 2 times 1, 2, minus 15. Y is equal to, there we're going to get negative 1 minus 15. So y is going to give us what? Negative 16. So therefore, this is the minimum value of y as we are required of to find in the question. So we can even say, therefore, the minimum value of y is equal to negative 16. If they ask you to find the coordinates of the turning point, you're simply going to list these coordinates. Okay, coordinates of the turning point are going to be negative 1, comma, negative 16. And you are done. So that is how we solve question 1. Let us now go to question 2. So you see how quadratic equations and expressions are very important. They are also connected to this question. You don't know how to solve quadratic expressions, meaning you also won't be able to solve this question. And this question always comes in paper 1, mathematics paper 1. So you just need to make sure that you know how to solve quadratic equations so that this question becomes a free mark. So that's question 2. And then the question says the sketch represents the graph of y is equal to x squared minus 6x plus 5 passing through A, B, and C. So this is the curve passing through A, B, and C. And here we have the equation of the curve indicated. That's our y-axis, that's our x-axis, and then we have our 0 here. Okay? The question says find the coordinates of Roman numeral 1, A and B. A and B. How do you find the coordinates of A and B? Remember we said to find the coordinates of any points that are lying on the x-axis, we need to use the equation they are giving us. We simply solve it as a quadratic equation, and then we'll be able to find the x coordinates. Since we already know to say their y coordinates are zeros, right? So I'm going to say x squared minus 6x plus 5, okay, is equal to 0. So we need A, we need B, we need C, we need the sum, we need the product, we need the factors. So what is A? Our A is 1. B, negative 6, which is the same as the sum. Our C, the constant is a 5, positive 5. The product is found by multiplying A times C, so 1 times 5 gives us a 5. Our factors, what are the factors of 5? Just 1 and 5. And then we make sure that the biggest factor has the same sign as the sum. Our sum is a negative, meaning this guy has to be a negative. Then we test. 1 times negative 5 should give us this one, the product. But the product is a positive. And if you remember the lesson we had on integers, I'll keep reminding you because I want you to make sure that this sticks in your mind. It should just be on your fingertips. Okay? You can only get a positive outcome when you multiply either two negatives or two positives. So here, since our goal should be to get a positive product, but here we have, when you multiply this one and this one, okay, 1 times negative 5, this is giving us negative 5. So in order for us to make it a positive, we have to make this one a negative also, because negative times negative is the one that is going to give us a positive. So that this guy will be a positive. So meaning this is also supposed to be a negative. Having achieved that, we can go to the final test. When we add these values, okay, are they giving us the sum? Okay, so we're going to say negative 1 plus negative 5. Okay, our goal is to get a negative 6. Negative 1, positive times negative, to open those brackets is a negative. Okay, and then when the signs are the same, keep the same sign, you add, it gives us a negative 6. So meaning the signs and the numbers are correct. We can now pick them the way they are. So we have negative 1, comma, negative 5. Remember, we are doing shortcuts for this one. So we'll come back now to the equation. Here we check, okay, we have x squared. All right, so let me actually give you a disclaimer. In case your equation has something like, for example, 2x squared, when you come up with these double brackets and you equate them to 0, you have to include the coefficient there, 2x, 2x. Very, very important, okay, because you might get stuck in case the questions I'll give you will have a coefficient greater than 1 here. Okay, so you pick this x together with its coefficient. The reason why it's not not going to appear in this question and the previous question, the reason why it didn't appear was because it is simply a 1. So if you have a 3 here, you put a 3 here in front. Even there, you put a 3. Very important. Take note of that. All right. So we'll come back to our original equation. So there we just have an x. So we're going to just put an x in this one. In the other one, we put an x, and then we equate to 0. So these are our factors. So we're going to say minus 1 minus 5. And then we solve for x. So x minus 1 is equal to 0, or x minus 5 is equal to what? Is equal to 0. Right? So at this point, we're going to say x is equal to 0 plus 1. When this negative crosses, it becomes a positive. So the x coordinate here is a 1, or x is equal to 0 plus 5, or x is going to be positive 5. So these are the coordinates, the x coordinates for these 2 points. And if you check, actually, you notice to say, remember we said on the x-axis, from 0 going towards the right, you're going towards the positives. So if, for example, as you're finding these coordinates, you happen to find negative coordinates, you need to know, you need to check and see to say, I've actually missed it somewhere. Because these 2 coordinates are clearly in the positive region on the x-axis. So why do I have a negative coordinate? Alright? So that is why here you notice both of these coordinates are what? Positives. Here one is in the negatives, the other one is in the positives. No wonder they were different. Okay? But here they are both lying in the positive region on the x-axis. So therefore, both of the x coordinates you're supposed to find should be positive. So these are just some checks and balances you can be doing to make sure that you're doing the right thing as you're solving. So now, which one are we going to assign the 1? Which one are we going to assign the 5? So starting from here, the numbers are increasing. So this is going to be 0, 1, 2, 3, going upwards. So the one nearest to 0 should most likely get the smallest coordinate. Okay? Since it's closer to 0. And then the one at the end, which is a b, is one that's going to get the 5. So meaning the coordinates for A are going to be, the x coordinate is a 1, the y coordinate is a 0. We've already explained on why it's a 0, because the points are lying on the x axis. And then the coordinate for B, the x coordinate is going to be 5, 0 for the y coordinate. And we are done. We now come to the last one. Find the turning point of the curve. The turning point of the curve, we say first you need to find the x coordinate. To find the x coordinate, you can use either this one or that one. So we'll use this one. So we're now going to say, that is Roman numeral 2. This is Roman numeral 1. We're going to say x is equal to negative b over 2a. Okay? See the beauty of having a data table, you simply extract those values from there. So we're going to say x is equal to, what is our b? Our b is what? Negative 6. So you pick it together with its sign. This negative is for the formula, not for the number you are bringing in. Okay? So that is why I had to put this one here, and then the negative 6 comes with its own sign like that. You miss that one, the examiner feels happy. You will be gone. Okay? And then what's our a? Our a is simply a 1. You close, and then we're going to say x is equal to negative times negative gives us a positive. Okay? 2 times 1 gives us a 2. X is going to be what? 3. 6 divided by 2 is a 3. Now that we have found the x coordinate, we now need to use the original formula for the curve, or the equation of the curve, which is this one. So we're going to say y is equal to x squared minus 6x plus 5. Okay? And then since we already know the x coordinate, we simply need to plug it where there is x in the equation, and then solve to find the y coordinate. So we're going to say y is equal to, where there is x, we have to put a 3. So it's going to be 3 squared minus 6, open bracket, 3 plus 5, and then we solve. 3 squared does not mean 3 times 2. It simply means this 3 is being multiplied by itself twice. So this means 3 times 3, which gives us a 9. Okay, and then there we're going to say negative times positive, the negative. 6 times 3 gives us 18. And then there we're going to have a positive 5. Alright, so y is going to be, when the signs are different, put the sign of the bigger number, you subtract, and that's what we get there. Okay, and then y again is going to be sign of the bigger number, negative 4. Alright, so that is our y coordinates. At this point, they are saying find the coordinates of the turning point. They said coordinates. Okay, so that is why we're now going to say coordinates of the turning point. You can just abbreviate it as TP. It's going to be, what is the x coordinate? The x coordinate is the 3 we found here. What is the y coordinate? The one we just found here. And we are done. So now if you look at this point, the turning point is right here at the center where this curve is turning from. So to find the x coordinate of this point, we need to go up towards the what? Towards the x-axis. And since we're in the positive region, this coordinate will be a positive. That is why we have a positive here. Okay, when you go down towards this side, towards the y-axis to find the y-coordinate, it's in the negative region. That is why our y-coordinate is a negative, and you're done. So that is pretty much it. We have one more session to finish off. We need to look at two different type of questions. There's usually a question where they will give you the coordinates and then they ask you to draw the graph. And then there's also another one where they don't give you the equation and then they ask you to find the equation of the curve. They'll just give you the coordinates. Here the coordinates are hidden, the equation is given. Okay? They will switch it. They hide the equation, give you the coordinates, and then ask you to find the equation. So that is what we'll be looking at in the next session. I'll send the works in the group. Yeah. The work is also going to be composed of exam questions. Yeah, otherwise that is that. Thank you for watching and I'll see you in the next one.